Sure, go ahead. You'll be back in a minute, right? Good. Okay, good. Yep. So okay. So let's look at let me. I'm opening. I'm trying to um get the binomial expansion question. The one that I want to talk about. Mm. Mm. Yes, because there is this one more type of binomial expansion questions that we have not talked about. So just want to expose you to this type of question. Mm, mm, the coefficient okay, this is the one. I'm gonna upload it. Okay. You should be on slide 1. Can you see the question? Good. Nice. Okay, so let's start off with this question first. So I will let you attempt it first. You can start doing it if you are ready. So how? Part A. So you have to show that they don't have this independent term. That means you will never end up with a you know what's the independent term? We talked about it yesterday, right? Yeah, so basically you need to show that there is no x to the power of 0 term. Okay, what you start with? I mean, what is common? Whether they ask you for the x to the power 0 or x to the power 2 or x to the power 7 term. So what's the common? The 3 brackets, right? Nice, yeah. Mm-hmm. 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 Mm. Okay, in a way, right? So in fact, what you can show, right, instead of okay this approach, I think yesterday you showed me one formula. The formula is I think TR plus 1, right, if I'm not wrong. Then can then can you give me the formula one more time? Do you still have the formula with you? Hmm. hold on, hold on. N choose R. Boy, can you write it? Can you just write it? Help me fill up the formula. Yep, never mind. Just erase my. Continue. You mean the N choose R here? No. I mean definitely you should. No, you have to have 3 brackets. If not, it does not make sense. Let me see if I have that here. Yeah, I need this one. Yeah, I need this one. Yes, you're right. Remember, you always have 3 terms. I mean, you always have 3 brackets. Okay? Okay? If you ever get only just 2 of them, something is not right. Unless you can prove that you can delete or somehow you can that term disappear somehow. Okay? If not, always start with 3 terms. So what you need to do is you have to find out this one. Okay? Not find out this one, make use of this one. So basically, what you do is you try to get the t to the power 0 term. So t to the power 0 term is okay. Let me just park this formula just at the side. So I will just continue with this question first. So in order to get the x to the power 0 term, so you have a 15 here, right? So what this means is you have this 15 here, and then you have this. Okay, let's call this a, right? This will be your 15 minus a, right? And then this will be your a, right? Okay, then okay, so what you end up with is we just need to show that we don't have the x to the power of 0 term. So basically we don't need to care about the 15 choose a at the moment. So we need to expand this like x to the power 15 over x to the power a, because it's minus, so x to the power a is below, right? Then 1 to the power a, then 2 to the power a, and then I have the x to the power 3a, right? So negative 1 to the power a is 1 to the power anything is 1, so it's negative 1 here. Okay? So 2 to the power a, okay, I don't have to care about a, right? Because I'm not going to figure out that, because I just need to prove that there is no x to the power of 0, right? So I just need to focus on extract the x to the power of something term. Okay, so seems like over here I shouldn't write this, but I should write the x minus a. I mean x 15 minus a. Leave it untouched. So I don't have to solve many of the terms, because I just want to get what I want, which is this one. Let me use a different color, which is this one and this one. Okay. So x 15 minus a, right? Over x3a is equal to x to the power 0. I just have to prove that this one can never be x equal to 0. Okay? Right? So I just need to prove that it can never get x equal to 0. So how I prove? So I use the indices x15 minus a minus 3a, right? Right? Then x 15 minus 4a, right? Right? So in order to be x to the power of 0, in order to be this, right? So I need to find out what's my value of a, right? Okay? So I just need to get this 15 minus 4a equals to 0. So if you continue, your 4a is equal to 15, and then your a is equal to 15 over 5 over 4, which is, what's the value? Can you just punch your calculator and get a decimal number? 3.75. And I hope you know that your this a here, a is always a whole number, right? 0, 1 onwards, right? And then in order to get x to the power of 0, your a has to be 3.75. So it does not make sense, right? So that's how you show. So a is always a whole number. Okay, a is always a whole number, and in this case, in order to get x to the power of 0, a has to be 3.75, which can't be the case, right? So therefore there is no x to the power 0 term. Okay, does it make sense to you? Okay, yeah. So this is one way to prove. Yeah. Okay, that is also possible. But if you show the first term can be x to the power of basically, okay, what this question wants is not the first term or the last term. Because you see when you say first term and last term, right? Are you trying to say I want to get the smallest power for x term, right? Which is 0, right? You are trying to say. Actually, you don't know which one, because of the tree here. Because of the tree here. Sure. Okay. Let me show you. Let me show you. Because of the 3 below, if the x to the power 3 below, you get the 15 into it, it will be x to the power 45. And are you going to expand all out like 16 terms, because power 15 is 16 terms? Are you going to show 16 terms and then actually you don't know which one is the x to the power 0 term or the x to the power 1 term. I don't even know what is the smallest power for x in this case, right? Yeah. But actually with this answer, right, a is equal to 3.75, that will give me the x to the power of 0. I kind of like can guess, I can test a equals to 3 or a equals to 4 to get the smallest power for x. Understand? Yeah. So your logic of like testing the first and the last, I think it doesn't work in this case. Okay? Okay, so that's how you do the part A. So part B, right? So part B is actually the one that I want you to to learn. So what they say is that the coefficient of x3 and x4 is the same. So how you do this question? Yeah, go ahead. Yeah. Let me erase the. Can you start doing over here? It's funny, I don't get it. Oh, okay. I need to enable the camera to get the camera. Okay, it's okay. Yep, this one looks good. And how? You need to pick the coefficient. So the coefficient is this one. And you equate these two. Right? Wait, they say x3 and x4. How come you get x5? Okay. Hmm. So I think your this one you can cancel because 1 to the power anything is 1, right? And this one and this one I think you end up with k only. So all you need to do is you do the n choose 4 times k equals to n choose 3. And I guess, right, your k, right, you need to find k, right, in terms of n, right? So it's k equals to n choose 4 divided by n choose 3. And from here, right, you need to make use of the formula. You still remember the formula yesterday? Oh yeah, thanks. Yep. Yeah, the factorial one. Can you still remember that one? Yeah. Okay. So if you expand this, you get the, okay, let me just do the, this is n factorial, n minus 4 factorial, and 4 factorial, right? Right? Then you do n factorial, n minus 3, and n minus 2, then factorial, then 3 times 2 times 1 times, you flip it, is n factorial, this is n minus 4, then n minus 3 factorial, then 4 times 3 times 2 times 1, right? Factorial, okay, so this n minus 4 factorial is minus, n minus 4, it should be, okay, let me see, n is n minus 1, so minus 5, sorry, right? No, there is no two term, there is a factorial. Okay, hold on, let me just, I need to recall the formula. The formula is n factorial is n minus 1, right? I need to get this right first. N factorial is equal to n times n minus 1 and then n minus 2, then until right? Okay, good. Okay, good. Full stop. So n minus 3, so I'm supposed to be n minus 4. And then there is a factorial. Yeah, there is a factorial here. But I don't want to write so much. So then n factorial n minus 5 factorial. Because somehow I see that you can cancel. This one cancel. Then this one n minus 4 factorial is cancel with this. Then 3 to 1, 3 to 1, done. So it's pretty simple. So 4 left, below is n minus 3. That's it. Yeah. Okay. So k equal to this. Okay. So in fact for the n choose 3 and n choose 4, right? You okay? I don't have the formula sheet with me, so just go back and then just look at the formula sheet and you just do this one more time. But this is definitely the 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 the, the, the approach, okay, to do this question. Okay. Okay, good. Okay, good. So that's it. 7 marks. Okay. So with this, then we have completed this a binomial expansion chapter. Mm. Do you have a dog at home? Okay, never mind. Okay, good. Next. Okay, let's go to slide 2. Okay, see what you have. Mm-hmm. Let me see where is the formula that I. There is a formula here. Slide 9. Slide 5. So I'm trying to insert the formula to the slide 2. Yeah, we can try. Yeah, let's try. I have not proved trigo identity for quite some time already. Let's see if I have the luck here today. For me, proving the trigo identity, I will do it last. Okay, I will do it last. Yeah. For you, you have to do it last as well. Never do proving at the start. I mean, left hand side equals to right hand side. That kind of question. This one can, with the value can. Done. Okay, so I think is good that I have the formula on the right hand side because you need to use some of them. Okay, so what do you have here? You have this. I think you can make use of this, right? This one. Continue. Yep. And by the way, sine 30 is a special angle. Never mind, you continue first. It's okay. Just expand it. Just open the bracket first. Okay, good. So basically, this is okay. In fact, you should write the LH right hand side equal. Then you just continue. No, 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 no. Why you go and minus the cos? Oh, okay, 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 okay. That's the extra term. Okay, good. Yeah. Then continue to get the sine 30 degree. What is sine 30 degree? Special angle. Can you remember? Can you recall? Yeah. Did I not teach you? You don't have to memorize it. You just do it on the spot. This is 30. Then this is the 45 one. This is 1. This is square root 2. And this is 1. This is 2. This is square root 3. So sine 30 is OH, right? O is this, H is this. So it's half. Okay? So next time when you do special angle, remember just these two special triangle. Okay? Then you don't have to memorize the exact value. Okay? Good. So this is half, yeah. AH. This is 30, this is square root 3, this is 1, this is 2. So AH is square root 3 over 2. You can double check. You can like punch cosine 30 degree to your calculator and see if the value of that is equal to square root 3 over 2 and have me double check on the spot. And I think you can combine these two together. Yeah. Yeah, I think so. Yes. Yes. But does it help or not? So that's the question you want to ask yourself. It doesn't look like this helps you, right? Then it's okay. Then it's okay. Then you can do the right hand side. You can try to open the right hand side. I think the minus sign here, right? I think you just leave it like uh just put it out of the. So what I'm trying to say is you can do this one first. Then the minus sign you will just apply the minus sign later on. Yes, yeah, yeah, yes. There is no plus here. I guess it's times. Yeah, no problem, no problem. Cosine 30 is yeah, you can see here already. Mm. 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 Yeah. Yep. Okay. Okay. All right. Good.